Hi, in this lecture, we are going to continue our discussion on structured query language. After completing this chapter, you will be able to retrieve specified columns of data from a database, familiarize with comparison operators, restrict data retrievals through rows that match complex criteria, sort data in any desired order, aggregate data across groups of rows, and create subqueries to pre-process data for inclusion in other queries. Data manipulation language is a part of core SQL. A DML statement is executed when we need to add new rows to a table, modify existing rows in a table, or even delete existing rows from a table. The following is the syntax for us to be able to insert rows into tables. With this syntax, only one row at a time can be inserted. Character and date values must be enclosed within single quotation marks. Let us try to insert values in the Account Manager table that we have discussed in our previous discussion. When we insert a complete row of values, meaning we're inserting values for each of the column, we do not need to provide the column names. However, we need to list all values in the default order of the columns in the table. Otherwise, we list the names of the columns that we want to insert values for and the values for those columns. In our succeeding discussion, please take note of the following special values. We demonstrate this in the following examples. As we can see in the first one, we do not specify the column names anymore because we are inserting values for each of our columns in their respective order. In the second and third example, we are specifying the columns because we are inserting specific values for each of the columns. If we do not specify the values for some columns, the null value are implicitly inserted as values for those columns. Alternatively, we can also specify explicitly the null values using the empty string or the null keyword, as we can see in the example below. Whenever we are adding new rows in our tables, the values are checked for compliance with any applicable constraints. Let's take a look at this example. In this example, we are given the following error message because it violates the check constraint with the value that we are putting in our account manager region. If you will recall, M is not included in the acceptable values. The following are some more examples of constraint violations. In the first example, we are having a unique constraint violation because X400 primary key was already existing in our account manager. In the second example, we are getting a foreign key violation because there does not exist a customer with customer ID 2005. To change data in our tables, we use the update statement using the following syntax. Take note that the where condition is not required. However, be worried that if you do not specify the where condition, you might be updating all of the values inside your table. It is a good practice to use the primary key to identify the single row that you are trying to update, because using other columns could identify more than one row for update. In the first example, we are updating the AME date to be equal to October 10, 2017 for account manager with AMID equals to J500. In the second example, we have two conditions. We are updating all of the records in our table where the region is either northeast or northwest, and we're setting the region to be equal to west. In the third example, we can also update multiple tables at one time, multiple columns at one time. In here, we are updating the AME date and the region for AMID L500. What if for our orders table, we would like to add a default date for our ship date, so that we will not be getting any null values? Again, from our last discussion, we can assign a default date using the following syntax. Alter table orders, modify, and then the name of our column, the default keyword, and our default value, which is 7 days from our current system date. And then to update all of the null values currently in our table, we use the update option. So to do that, we do update orders, set ship date to be equal to the default, and in this case, our default is already 7 days from our current sys date, where our ship date is equal to null. We can delete rows from a table by using the delete statement with the following syntax. If the where clause is used, rows that satisfy the condition are deleted. A word of caution, however, all rows are deleted if we omit the where clause. So make sure that we have a where condition if we do not want that to happen. For example, if John O'Brien and Scott Castile are no longer working as account managers, we can delete their appropriate rows. To do so, we say delete from account manager, where, and then we use their AMID so that we will be sure that we do not delete any other rows. An alternative method for deleting all rows in our table is by using the truncate table statement. It removes all rows from a table, leaving the table empty but the table structure intact. This is fast, but data cannot be recovered, so the storage space is reclaimed. Database transactions can be viewed as a sequence of steps that accomplishes a single task. It could be a DML, DDL, or DCL statement. A transaction begins when the first DML statement is executed. It ends with one of the following: either a commit or rollback, or a DDL or DCL statement executes. After one transaction ends, the next executable SQL statement automatically starts the next transaction. The commit statement makes all pending data changes permanent. An explicit commit occurs when we issue the commit statement. An implicit or automatic commit occurs when any DDL or DCL statement is issued, or the auto-commit is set to on for the Oracle session, wherein each individual DML statement is committed as soon as it is executed. To remove changes that have not been committed yet, we use the rollback statements. The rollback statement without a save point reverses changes to the last commit. We can logically divide a transaction into sections by using save point statements. Then we can undo pending changes up to a marker identified by a save point. An automatic rollback occurs when a transaction is interrupted by a system failure. This returns the tables to their state at the time of the last commit. The following illustrates how we can undo data changes. As we can see, if we have save points, we can roll back to the specific save points that we have. However, if we only have rollback, we're going to roll back to the last commit of our transaction. This is the state of the data before we commit or roll back. All data changes made during the transaction are only temporary until the transaction is being committed. If it is not yet committed, the current user can review the results of the DML operations by querying the tables. But other users cannot view the results of the DML statements done by the current user. This is what happens if we have commit or rollback. After commit, the changes are made permanent in the database. The previous state of the data is permanently lost, all save points are erased, and all users can view the results of the transaction. If we have a rollback, all the pending data changes are undone, and the previous state of the data is restored.